Good morning. First day, 8:30 a.m., 5:30 a.m. for me. Lots of coffee, caffeine. How you guys doing? Good. So, I'm Fred Melo. This is William. We both work at Piro. And this session, I think it's especially exciting for me because it's a big data-driven track. It's the opening of the big data-driven track. But it's also a matter of passion because of machine learning, intelligent systems. I've been studying this for quite a while. And what we're bringing this here is actually a pretty cool talk that will show you step by step how we can use Spring Framework and other open source projects related to it to build a really nice stock prediction demo or stock inference or however you call it. And it basically sets a baseline in a reference architecture for any machine learning real-time data streaming pipeline system. So the way we're going to do this, you're going to set a little bit of expectation, what machine learning is, what really you're trying to predict, how things work in general. Then we're basically going to present the reference architecture, explain how things work. I'll hand the ball to William. William's going to go through each of the pieces and explain basically what each piece does. So you're going to go through a little bit of SpringXD, a little bit of Apache Geode, a GemFire, a little bit of Spark, and Lib, that's what we're using for inference. And then we're going to go through a demo. You guys are going to see this all working together nicely, hopefully. Everything we're going to present is open source, from the products to the code of the demo itself. It's available on a GitHub repo that everybody can check later. If we have time, we are happy to walk you through the very, very simple source code as well. It's mostly Spark source codes. The other things, we really don't need source code. And that's actually the cool part of this. Feel free to interact with us if you have an answer that question that can't wait. Otherwise, we'll leave time at the end for like 10, 15 minutes for Q&A. Okay? Cool. So what are you trying to do? We're basically trying to apply what we call is machine learning. And what machine learning is, at the end, it's basically a way for the machines or to the systems to learn with practice and try to predict things based on that learning. So we're going to go a little bit deeper and explain how it works. But it also implies a lot of interest characteristics, how you interact with the inputs that you're getting from each system, what you're trying to predict, or how you make the algorithm learn. And there are different kinds of machine learning techs can you apply. Basically here we're going to be using something that can be used for a neural network or a linear system. We're going to explain this a little bit better. Hold on. But at the end of the day, it's all about data. So every time you have a system that tries to predict something, you can apply very fancy artificial intelligence concepts, but at the end of the day, it all tries to mimic certain types of inputs. So whatever you're reading, your readings are about the environment, and try to predict something. If you try to make an analogy, or actually how we do this ourselves, human beings have been trying to predict, for example, weather forecasts for a while, right? And the way we do this, we basically take in consideration different variables. One of the variables can be, for example, what's the moisture on the weather right now? How strong are the winds blowing? What's the temperature? So we take all those readings, and we basically try to correlate this with what we've seen over the years. And then it looks at, okay, in similar situations for the last 15 years, when you had 58 degrees outside, the wind was blowing this direction, strong, and here we have this kind of air moisture. It looked like 47% of the times it rained over the next hour. And that's basically what we do all the time when trying to predict stuff. How we basically connect those inputs in our brain to predict an output, or how you actually correlate the live data with the historical data you're teaching the algorithm to, it's a very similar way that we actually learn ourselves in our brain by making those connections that we call synapses. And most of the times that we're doing artificial intelligence or machine learning, and specifically you're looking in things like neural networks, you're trying basically to mimic this behavior from our brain. And what basically do we want to build today? Well, we want to build a smart system that looks at those inputs and basically can be used to predict any kind of behavior. In this specific task, we're going to be doing something related to stock values. We're going to work you guys to what the inputs and outputs are going to be. But you can pretty much use this for any kind of predicting task. We've been using this extensively for web search. For example, Google used this extensively. Object recognition. If you're old school and had a Palm, for example, that small device, they use that like stylus to draw things. You can remember that it actually understands your calligraphy. And basically when I do like this, it says, oh, it looks like an A. How does it do it? You basically train an algorithm, a machine learning algorithm, to identify similar A's, and then it gives a scoring. You might not do the exact same perfect A that we did when we were training the algorithm before shipping the product. However, if it's like 84% accurate, it can look and say, well, it looks like an A, so I'm trying to guess this is an A. So it's a very similar thing. It's basically object recognition. And what we're actually trying to do today, more related to our use case, is to train the algorithm with a historical data set of stock prices, what we call technical indicators. There's like, what's the median of the price, and what's something that we call relative strength, which is how many upsides compared to downsides we have over the last previous 10 measurements. And as we train the network or the algorithm with that, saying, this is the latest 2 years of data, and this is how the inputs or the indicators looked when the stock was really high, and this is how it looked when it went to a downside. You train extensively on that, and once the algorithm is trained, it's basically ready to compare the historical trends with the live data coming in. And then you give a prediction. Say, well, based on this price, this latest movement, and this median average, it looks like next step is going up 0.3% or something like that. And we're basically predicting data over the last seconds. So it's really real time. You can use this for doing next day, of course, next week, forever. So again, it's an example. We can actually extrapolate that. But anytime you have a smart system or a machine learning system, you basically need historical data and real-time data together. It trains the algorithm, it learns over time, and then it evaluates against the real-time data. One point to understand is actually when you stream that data in real time, what is current data eventually will become historical data in the next few seconds. So data ages, so it eventually becomes historical data, and you're constantly retraining the algorithm. So as we're evaluating it, we also constantly retraining it in parallel. So actually the next trends are quickly caught up by the algorithm, who's constantly retraining. So it's something, if the waves change, the algorithm is supposed to follow that. And we can see that actually in our example. So I said that first we train the algorithm, and then we try to predict it. So as I said, we have inputs. Those inputs are commonly called features. So whenever we say features here, I mean whatever you input in your algorithm to. There's a step that we call feature extraction. Basically, we want to scale the data to look similar. So if I have a price, for example, and we're going to be using the Tesla, for example, stock prices here, which is between $240 and $260, for example. And I'm using another, basically, technical analysis number that is giving me a number that is between 0 and 1. If I try to put all this together in the same algorithm, any changes in the price, we have a much bigger impact than in that 0 to 1 level, of course. So first, we basically scale everything to the same range, so they're equally important. Of course, you can tune these things a bit, but you basically first scaled it. That's what we call feature extraction. And then you input all those numbers to your algorithm, and you said, you know what? When I have these inputs, the output was that. As it has historical data, you can look back and see what happened. So you basically teach it, this is the output I was expecting you to give me. This is the prediction. And then it looks at the inputs and outputs and adjusts its internal weights to get as close to that number that you wish. And you keep doing that with each data point. You give the features, you give the result that we call the label, and like, this is what I'm expecting you to give me, and this is what I will give you as an input. And you keep training. You do several million interactions. It adjusts its weights internally. At the end of the day, when predicting, I just give the inputs or the features, and it will basically give me the label. And this is how the data flow looks for the system. So it's a little bit complex, so I'll walk you through it. First, we're basically capturing live data. That live data comes from Yahoo Finance, just because it gives us a very convenient and easy way to do a query over REST interface that will output JSON, so it's perfect for us to treat. If the market's closed, and unfortunately the market is still closed, we prepare the simulator, and what the simulator is going to do, it's going to replace some data we captured a few days ago that's already sitting there. It's pretty much the same. So basically, I input live data that is coming from this Yahoo Finance stream. That, after some treatment, and the treatment we'll do in SpringXD, we explain everything how it works. But basically, the treatment can be, I'm converting formats, I'm ignoring some of the input that I'm not interested in, I'm converting numbers from string to numbers, I'm parsing things up. And then as the data arrives in an in-memory data store, and what do we need an in-memory for this? Just because you might be receiving millions of points a second, it's a lot of data. If you just try to persist this in Hadoop, for example, or as an analytical system, it will be too slow to transact in real time, right? So you need a transaction, really fast, low latency, high throughput system first to store your real-time data. As that time ages, that can actually overflow to an analytical system that is much more suitable for queries, ad hoc queries, distributed analysis, et cetera, et cetera. It's an analytical system. That can be done, for example, as a Greenplan DB. We're going to see in this case, we simplified things a bit, and that all the data pieces in Apache Geode or Pivotal GemFire to make it simple enough to run in our laptop. But anyway, I said you input that data into this in-memory data store. After that data is input, you basically send that data directly to a machine learning model that was already trained. That machine learning model basically compares those inputs, which the inputs and outputs it was trained with, and say, well, it applies a scoring. The scoring can be, it looks like 85% chance of the price going up within the next 2 seconds. But while you're actually evaluating each of the inputs coming in, we also retraining the algorithm all the time with the data that is sitting in the historical data set. In both the data coming live, the raw data, or the price points raw, and the predictions, we are plotting to a chart. There's the dashboard. So you can compare what's happening to what's being predicted live. And then we can adjust basically the algorithm to be closer to what we needed. We simplified this a bit, as I said. So for this demo model, we only leveraging Apache Geode for storing the data. So it's serving both of the historical data and the real-time data set. As we are predicting next second things, our historical data is not very large. We basically train it with a few hours worth of data so we can store everything in memory. If I wanted to predict maybe in the next week, I would need to train it with years and years worth of data. So I really would need an analytical system to store this analytical database. That's why we're basically doing very real-time things in this demo. Any questions so far? And if we start to see how we apply those technologies to realize this business use case, and start to put names here on the products, what we're basically doing is creating a few streams in SpringXD. And by the way, who is familiar with SpringXD here? Told you. So we see a few hands. Apache Geode, Pivotal GemFire, in-memory technologies in general. Great. Last, Spark. Good, that's going to be interesting. So, a lot of you guys are already familiar with SpringXD. We're going to explain the basics regardless and walk you through how the streams work. But basically, SpringXD data pipeline system, we're going to create what we call the data pipelines. And the pipeline is very simple. It's basically going to query Yahoo Finance or open an HTTP port for the simulator to ingest the data to us directly. It's going to apply some simple transformations to data. And one of that transformations is basically enrichment that uses an R script to generate some indicators based on the data. If you're not familiar with R, or you're not familiar with finance indicators or technical indicators over finance data, don't worry at all. It's a very simple source code. And what basically does it's some math calculations or statistical calculations based on the data we have. So you find median points, standard deviations, et cetera, et cetera, et cetera, and basically replies back with SpringXD with those additional data points or enrichment data they want to put in our stream. And basically, SpringXD sends all this data to Apache Geode or Pivotal GemFire that's basically going to store that data. That data gets stored on a different regions in Apache Geode. If you're not familiar with key-value NoSQL stores, Apache Geode is basically like a map or a hash map on steroids that replicates things, provide high availability, et cetera, et cetera. So we have 3 special maps. One is basically storing the raw data with stocks. One is storing actually the raw data with the technical indicators are put for us. And that's actually what's being put on our machine learning model. And as our next step on the stream is sending data for Spark to predict, Spark replies back with the predictions. They're stored on a different region. So then if we go to Geode or GemFire and query those 3 regions, we can actually compare the raw data with what was enriched and what was predicted. So it gives us a pretty cool way of basically looking into data and understanding what's going on. And last, we basically have a dashboard that is JavaFX. We use Spring Boot as well. There you can basically read all those 3 regions and chart things up, et cetera, et cetera. All the solution So why choosing the pieces here? William will talk a little bit better about the specifics of why we choose those products or projects to be part of the solution. But everything here is totally extensible, horizontally scalable, every single piece. Basically, it's fault tolerant. And most important, it's cloud native. We can deploy any kind of cloud and infrastructure environment we wish. We did this talk in a conference also a while ago. We're basically running all this in Dockers. I ran this in Lattice myself. So we can deploy across clouds, across different infrastructure environments. That's a +1 for this kind of architecture as well. So to understand how all things work in general, we'll basically start eating that in small bites, as I said. So let's start understanding a bit on how GemFire or Apache Geode worked for this scenario. Then let's jump to SpringXD a little. Let's understand how Spark and Lib works. And then we go through the demo and walk you through the source codes. So William's going to take the lead on that.
Morning, everyone. So basically here, we are going to cover some concepts and basics about each product. So I saw that some was already familiar with SpringXD, Geode, and whatnot, but I guess it's nice to set like the base for everyone, so cover that a little bit. Starting with GemFire, we are really trying to summarize things here in one slide. So the basic concepts here, of course, what's a cache? Collection of regions, or it's the basic thing you configure in GemFire. You can do that using our own XML. You can do that using Spring, thanks to the Spring Data GemFire project. You can also use our Java API. It's the base that you set when you start a GemFire or Geode server, right? Since it's a collection of regions, then what is a region, right? A region, as Fred said, it's a way to think about it. It's a hash map on asteroids, or some people also like the analogy of tables, although we are not actually, we don't actually have columns or stuff like that. We're actually storing objects. Regions can be, of course, redundant, highly available, persistent, and all that. They can also, of course, most of the time when we are talking about GemFire, we leverage performance, and we are talking about in-memory, but that data also can be persistent in disk and in HDFS as well, right? Just a matter of specifying a setting there. Also, of course, we are talking about a clustered system. The members here, they have a special name, or it's important to identify what members, what kind of members we have. So, for example, we have a server, of course, which is where data is actually hosted, right? Clients, which has an interesting concept here in GemFire or Geode, because clients also can host some data, so you can leverage locality, data locality as well. So client can keep data that is important for that particular client close to it, cached a little bit in the client itself, if needed. And we have also the locator, which act as a kind of a DNS. So it's a way for you as a client to discover all the members that are part of the cluster. And then after that, you establish a connection to the server. And then from now on, you are talking directly to the server, right? And it's also important to know that we have callbacks. And of course, for that, you may want to filter data before it actually enters in the region. So you have like cache writers, listeners. Most of them are synchronous. Then you have the async event listener backed by a queue as well. And it can be parallel or serial. So basic concept here. Many others, of course, around GemFire, such as gfish and stuff. But I'll keep it as is for now, and then on the demo. And if you have any questions, we can talk more about that.
And just to go there, just an extra mile on that. GemFire will be perfect for any kind of use case that you need a scalable system that basically reacts in very low latency. You can input a lot of data, and you want to either get notifications or whether data coming in, or leave some query running on it continuously, basically interact with that data on a very low latency, high throughput behavior. As one of the mottos of this conference is cloud native applications, if we look on what we're expecting from the applications today, we should be able to scale horizontally, be essentially 12-factor based, which means stateless, be able to run in any cloud environment, be able to start up new containers on the fly. You basically throwing all that pressure of reliability, scalability, on where the data is being held. That's basically the backup data store, right? Your basically application that is station is stateless, and where all the state is being held is basically at a data store that sits underneath it. So having actually a database or a data grid that can actually scale with your app, as you spawn more instance of your app, it increases the pressure on the data side. You can actually scale that horizontally in any environment. Bring a new node up in less than a second. Scale down when needed. Replace failed instances automatically. That's actually what you want to get from a solution that needs to be built for cloud native applications. And that's basically what GemFire is. One of the reasons we're using it is because when you actually scale with SpringXD, you input more and more streams. You can actually make GemFire scale horizontally in parallel with that.
And of course, then people always ask why GemFire is so fast, or why choose GemFire, or Geode, right? And I guess trying to summarize the three top reasons here, right? Of course, performance would be one. And when we talk about performance, there are, of course, many aspects of performance and many ways to do it. For example, right, giving a very simple example, Geode clients, they can fetch metadata from the servers, and based on this metadata, you are always a single hop, a single network hop from the data that this client actually wants. So you don't need to go look and touch all the servers for a particular key that you are looking for example. Based on this metadata, I know exactly where the data is, and I just have a single hop to that data. That's one way that you can improve performance, for example, through a Geode client. But then there are, of course, other concepts around performance as well. Such as, of course, internal details, internal implementation details around highly concurrent data structures. Thank you. Use, of course, of specific data structures, optimized network between the nodes. So the way GemFire or Geode deals with data transmission between the nodes is in a very efficient and consistent way as well. So there are many aspects of performance that make GemFire fast and scalable like that. There is also, of course, around, for example, persistence. The way we persist data, we use a write-ahead log, so writes are really fast. And then when we are looking for data on disk, there is a specific file that we just store the key, so it's also fast to get all the keys and then actually look for a specific data point on disk as well. So indexes, data. When we talk about consistency too, we also have, I guess that's this slide here, maybe easier to explain. When you talk about resilience and consistency, right? So data, as I said, you can have redundant copies. So if one particular node fails, and the redundancy level is actually lost. So you ask for 2 copies, and then now you have only 1. So the system detects that and automatically copies the data to a different node to reestablish the redundancy level that you specified, that you asked for. If you are executing functions, which is another way to do distributed data processing in GemFire, and if you have a failure during these executions, then you can specify that the function has HA, and that you want the function to be re-executed in a different node because of the failure, right? So that's also just a flag that you can enable on a function. Then, of course, we are talking about distributed systems, right? And network partitions, they are very real. They happen quite often, actually. And there are, of course, specific failure detection algorithms that we implement to have to prevent or to try to make the system consistent, right? Using like split brain detection. So there is also features, of course, for WAN integration. That's one of the few features that are not yet open source, but it's part of the pivotal GemFire. So when you talk about GemFire, this is a very, these two are very interesting use cases. We have more use cases in the pivotal website. Here we are talking about, of course, China Rail and Indian Rails. So considering here some information about their systems running GemFire, these numbers are mind-boggling, I think, because 1.4 billion page views per day is quite a lot. And in this case here, they are using GemFire as a session state cache, which is also a way to use it. And in the case of Indian Rails too, they are supporting 120,000 concurrent users, again, on a web app. So that's quite a lot, right? And another way to put those numbers that I found very interesting too, if we consider the population of China and the population of India, right? We like to joke internally that around like a third of the world population is actually using GemFire for a ride. That's a nice way to put it. It's quite a lot. And then just to compare the open source version versus the pivotal, right? So Geode and GemFire. So Geode was open sourced in 2015. Everything we are using here is actually using Geode. We are not using GemFire for the demo. So I guess the key features here that are still only in GemFire is one gateway and event subscriptions, although we are actually using something similar to that in our demo for the UI interface. So you're going to see that it's actually, there's a workaround to use that as well. Contributions are welcome to the open source project. So we are currently doing incubation under ASF. So please join our mailing lists or participate in the community. Like if you are a user or if you're just interested about our technology, want to learn more, please just join us. Let me see how I'm in time. Okay, I'm good. So going for SpringXD. So as far as I remember, we got a lot of hands up with about SpringXD, so I'm going to do this kind of quickly. SpringXD, of course, when you're talking about the very basic concepts, we have input, we have a sink, we have some processing steps, streams, pipelines, source sinks. The nice thing here, of course, is that you are pretty much doing system integration, leveraging built-in connectors. So you don't actually have to code that much. And just to show that, talking a little bit about the architecture before, SpringXD, of course, has also the concept of a cluster, and it's also a distributed system. So there is a concept of an admin. You can have multiple containers. When you are actually asking the streams to be created, you are talking to the admin through a REST interface. And after you do that, then it actually dispatches the command to a container, and the state about this command is actually persisted in a zookeeper and distributed and whatnot, right? When data is transported between all these containers inside SpringXD, you can use I think two different types of data transports, Rabbit and I forgot the other one.
You can use Redis. You
Redis.
Can use Kafka. You can use Rabbit.
Yeah. And to show a quick example here, this is actually one example of what actually would look like if you have like an input such as Twitter, and then you are actually piping that to store on GemFire. Actually, the entire thing is like this because, of course, you have to provide a key, and here, of course, we are also specifying what kind of output you are using. But it's actually very simple because, as you can see, you are not actually writing code. You are pretty much using the DSL that SpringXD offers, right? And having a nice integration. Reading data from Twitter, right, live, for example.
So as we use SpringXD in our own example, told you that we're basically using that as an integration layer to read data, for example, from Yahoo Finance, do some transformation, and then put data in GemFire or Apache Geode so you can actually predict, right? So that's basically the kind of thing that SpringXD does, because you have as a source a query and YQL, Yahoo query language, the RESTful API to get the data from Yahoo. With that data, we need to apply several different transformation steps. We need to filter data. We need to go to R and ask it for put some actually technical indicators for us. We need to take the data that is actually in a varchar or a string and convert that data to numbers. We need to adjust and do some scaling on the numbers. So those are all transformation steps in SpringXD. And at the end, we're basically sending data to GemFire or Geode. So that's actually, we're going to show it how's it done on a visual way, but that's basically on a pipes like any Linux command that you're piping. So you do basically search, pipe, send this data to R, for example, for enrichment, pipe, filter that data based on a JSON payload, for example, pipe, send that data to GemFire Geode. So all that you normally would basically program, open an HTTP listener, and then program something to handle that input request, and then apply some filtering to that, and then calling R, et cetera, That's all built in SpringXD on a basically descriptive language that you can just use those pipe commands into it. So walk you through the streams they're using, but it's very, really basic.
Yep. And now, of course, the last bit here of our architecture, right, is Spark. Again, trying to give some very basic concepts. RDD, data frame, driver, and worker. Of course, that the Spark project is actually not only Spark anymore, right? There's Spark SQL, Spark Streaming, Spark GraphX, and actually the mic is kind of not really good. Anyway, and of course Spark MLlib, which is the actual project we are going to use here as well. This definition of an RDD came actually from the creator of the Spark. A nice way to summarize it is that an RDD is an immutable partitioned data structure that, since it's partitioned, you can actually distribute the data processing to many nodes. And if failure happens, what an RDD actually does is, since it's immutable and has all these steps, all these partitions distributed, and all the steps of operations that you are doing against this RDD kind of stored in a lineage, if some failure happens, right, you can actually quickly restart and repeat that step from where you stopped. And since the data is actually immutable, you don't actually have any problem around modifying the actual data that is stored in the Spark.
1 second. Who wants to explain that again? RDD? Can you speak loud? What an RDD is. You want to explain that? No.
Okay.
Just want to make sure.
Good.
So,
yeah.
Again, why using Spark? What an RDD is. RDD is the main construct of any Spark system. That's how it handles data. Distributes data to different workers through what we call partitions. And basically Spark, so as you, for example, I'm sending all this data that I wanted to predict, all those inputs, I send it through data structures that we call RDD. Spark not only knows how to distribute and process them in parallel, it also knows how to rebuild all that data if it needs. So one of the nodes fails, it knows how to rebuild or reconstruct that data that we call RDD and redistribute in different nodes. So on the same way that as I'm storing data in GemFire, if I kill one of the nodes, we then said the node restarts, basically the front, and I redistribute that data. If you're actually using Spark to transact that data in parallel, and one of the nodes is down, lose one of the nodes, it knows how to restart that processing and recreate that data on the fly. It knows all the steps needed to recreate that data, so you can actually restart and recreate that data. So that's resiliency. I have basically SpringXD inputting the data. It distributes to SpringXD nodes, process data in parallel. One of the SpringXD nodes is down. That data can actually restart from that step on the stream that is stopped. It can be restarted on a different node. I'm storing data in GemFire or Apache Geode. If that data or one of those nodes is down, I can just restart a new node. It will redistribute, rebuild the consistency model and all the resiliency. So I still have high availability. If I kill one node, if I kill two nodes, if I kill entire cluster. And the same happens with basically as we're processing with Spark. That's the costly point, for example, is training the data. If I'm training my model and for some reason I lose part of my cluster, that cluster knows how to restart that processing with the remaining members. If I add a new member, it knows how to restart the process with the additional member as well. And more important than that, it knows how to recreate the data so it can actually keep data consistency and data high availability all the way over. So in all parts, there's like streaming, storing, and processing. You have essentially horizontal scalability and data resiliency. Right? Yes?
What's the difference between Spark and MapReduce?
They're very different things. So the question here was, what's the difference between Spark and MapReduce? So Spark is a distributed framework that will not store any data and will basically be used in a distributed systems. Does it need to be Hadoop? Not at all. And here we're actually using Spark to read and write data. As I said, it only processes, it does not store any data. It's entirely memory. So it's actually reading and writing data from and to GemFire or Apache Geode. What it knows how to distribute data, process in parallel, it basically has a much more complex structure and library. You know how to do basic scatter, gather functions, but also filtering, machine learning, graph processing, etc., etc. MapReduce, I would say, is a very raw processing framework that basically is attached to Hadoop. And what it does, it's much better for batch processing, right? And what it does, it basically knows how to do MapReduce. So Spark really goes a step, I would say a few steps beyond that, but it's not only attached to Hadoop as well. Any other insights on that?
Yeah. Actually, so on the Spark website, the thing that they have, like the first thing they have there is a comparison with MapReduce, and performance-wise, I mean, it's like I don't remember the exact number, but I think it's like 100 times faster than like traditional MapReduce. And on this particular picture here as well, we are talking about the cluster manager to distribute processing. So the same way you can use MapReduce 2.0 using Yarn, you can also leverage Yarn to distribute the Spark processing as well, but you can use Mesos, you can use other technologies too. But the concept of RDD and the way you can reproduce the lineage of data processing, and the idea of leveraging in-memory cache, the implementation, of course, of Parquet that also is like baked into Spark. So the idea of processing data using columnar and storing that in memory using columns, so you can perform queries, so you can perform even like any kind of job using columns. So those are like slightly I'd say, very different actually than MapReduce in a way, but you can also do certain things like that in a MapReduce too. The only problem or the only difference is that you have to do it manually, right? You don't have a nice framework or API that provides you that.
Even for the resiliency, you need to control all that recreation of objects and restarting, etc. And Spark has that beauty. You can see the Spark, it usually is used, well, one of the ways to interact with the Spark libraries is through the Scala language, functional language. You can see that basically our source code in Scala is probably like 20 lines of code. If you want to build that, something that doesn't provide all that structure, you would really be much way complex.
So just to summarize here very briefly, right? So when you're distributing these Spark jobs, you go through kind of the similar model as Yarn, for example, right? So you have a driver program that's actually the program you want to run on the cluster, and then you send that to a cluster manager that can be Mesos or it can be Yarn, and from there it actually sends the task that is actually going to process to all the worker nodes that has the partitions for your RDD, right? And just to kind of talk briefly about the data frame as well. So RDDs, if you're actually going to execute like SQL or using the Spark SQL API to query data, right? The RDD doesn't have a schema on it. So what the Spark guys did is pretty much to create a data frame, which is a way to just attach or add a schema to an RDD. So now you have types, you have columns, and you know how to query that data. And still everything we said about an RDD applies to a data frame. So we don't run out of time. So remember that Fred uses this image to talk about the machine learning model, right? So we have features, labels, and we are running a machine learning algorithm. So when we map that also to Spark MLlib, it's actually very similar to. So our features, of course, for the stock prediction system would be the price, the median average, and the strength of the stock. And then we have a simple algorithm that we are running here, which is, of course, the linear regression. And then the label that we're generating for this is just the median average, right? Moving average of this. Of the next guy. And just to get back to the architecture, right? We covered SpringXD, Geode, just R that we are not really talking much about it here, but that will be also part of the demo as well. So let's have more time for the demo.
It's yeah. So this is how you're gonna set this up, right? So as we looked, just another quick review of what we're building, so you guys can see what we're really producing here. We're gonna basically start first Apache Geode. So I'm basically gonna run a script. I'm gonna walk you through the script anyway, so don't think I'm doing anything. What we're basically doing here is first starting what we call a locator with a member in GemFire that all it does, it handles membership discovery and basically metadata. So basically starting a locator, that's the way the client will interact with it. Next, we actually start a server, a very simple GemFire server. Let's go back here. And then we basically create the three regions that we mentioned. Stocks, that's basically storing our raw data. That's the first one here. Actually, let me make this a little bit bigger. Okay. So basically creating the stocks region first, then we create the tech indicators region, then we create the predictions. I'm basically gonna, as the stock market is closed now, we gather some data over the last few days. So I'm basically importing data. I've imported 41,000 points for stocks. Basically, I already analyzed some of that data for indicators, just producing the indicators we use for input. We have 36,000 points here, but we basically have 0 predictions because we're gonna predict stuff live here. So I just started a GemFire cluster. If I connect to that cluster now, and let's
quickly here, this is gfish. It's the command line interface for Geode. Yeah. So using this interface, you can connect to a running cluster and then execute simple administrative commands as well. So you can start a new node, you can stop node, you can check like the health of all these nodes as well. You can check information about the region. So for example, now Fred is just doing a describe on the region. You can see the number of entries you have. You can see that this particular region has a data policy which is partitioned. So data is also spread and partitioned between the Geode nodes as well. Now he just executed a query using an OQL, which is a syntax very similar to SQL, but it's for objects. It's actually a formal standard for querying objects. So instead of table, of course, he just uses /region. And here's all the data that we have inside the stocks region. It can understand, of course, the columns here are, of course, the fields inside the object.
good. And then next, as we already have some data to read, still going to predict stuff. We're going to basically start SpringXD. Takes a few seconds to start. This is basically a single node. So I have both the admin and work nodes running here on my laptop. And that's what we're going to use to deploy our flows. And if we click here, we see the container is already up, but we don't have any streams deployed. We can also use SpringXD shell to show that, and stream list. And list the streams, you see we don't have anything deployed. But now we're going to do, as we already created this Apache Geode regions, we're going to create the basic 3 streams here that we set on basically on SpringXD. First one, we'll read from Yahoo, apply some transformations, and send this data directly to stocks. That's the raw data. Second one, we'll get data that is input here, also from Yahoo. Then apply some enrichment with the indicators calculated by R, send the data to tech indicators, and then as a third here, after that enrichment, we're actually gonna call Spark for our machine learning system, basically our machine learning library, and send the predictions back to predictions. So as I ask it to create the streams, and we're gonna see how those streams look like. They are being created in SpringXD. And let's see how they look like. So the UI is already updated. Let me make this a little bit bigger. So we are basically reading at any time the market's open, and this is specific time zone, I'm sorry. So from 7 to 1 p.m. every Monday to Friday, we're basically making an HTTP call. That's for the Yahoo API's query. We basically query for the symbol, last trade price, last trade time, et cetera, from the Tesla stock. And whatever comes out of that query, we're basically splitting the data, only capturing the results, the code of the results, and then sending to what we call a named pipe that will process that further. Apply a simple transformation. I'm going to open that source code so you can actually check. It's a 2-line of Groovy. We convert that to JSON, and we store in GemFire. So that's the first step. Reading from Yahoo, transformation, very simple Groovy, storing in GemFire or Geode.
And the ESL
And here it is, beautiful in SpringXD. As you've seen, I basically ran a script that already had that, but if I wanted, I just click create stream and drag and drop stuff, I can actually start doing it here. So, and this is the result. Well, after we just send that raw data to GemFire, next step, we basically catching what we call a tap, so it's a parallel stream to try to enrich that data with the indicators calculated by R. So I do a tap, that means a parallel flow, from basically from that process that we read. And from that, we basically making a conversion to JSON again, because R will expect JSON in this case. And then we just call a shell command, rscript technicators.r. So you can pretty much call anything you wish. In this case, I'm calling it rscript just because it's very easy to calculate all that in R. It already has the libraries to calculate the tech indicators that I wanted. What comes out of that, I'm basically removing each and a n, not a number, just because if I catch this right before the market opens, or if I try to get it on the time, there's no data point, it's basically gonna not a number most of the indicators. So I'm basically filtering that. I didn't want to write any source code, so I'm really using SpringXD to do that filtering for me. And what comes out of that filtering, that means the data they already expected, I'm basically converting to JSON and storing GemFire again, but in a different region that's called tech indicators. So that's step 2. Third step, I'm getting a tap out of that processing after I've enriched with indicators and calling Spark. So I'm going to do that tap from the R processing, converting to JSON, and again, calling a shell. There's a Spark connector that I didn't need to call the shell. I'm using actually an alpha release from Spark, a very new release that had something I wanted in terms of machine learning. So I just called it on a shell. You can always do this. And basically, it's a script. I can check that script together. And next step, what comes out of Spark, I basically store back in GemFire or Geode, basically on the predictions. And you basically can expand and check it out. Last, so I've already covered 3 of those. As the market's closed now, and if you have a few minutes at the end, and the market's opening, we can actually run that again, but you can also do that back home. But as the market's closed, I've also opened a stream that is an HTTP source that all it does is listen on the HTTP port 9000 and sends that data to processing after getting all the payload. So I get all the payload and send that data to processing because that's what my simulator, Spring Boot simulator, is going to do. It's basically reading from Gem and basically posting HTTP request to SpringXD. So it's basically emulating that query from Yahoo happening. Exactly it. So all these streams are deployed. So all these streams are deployed. It should be fine. Next step, I'm basically opening the GUI. And that GUI, it's basically our dashboard here. As you can see, it's a Spring Boot process that just uses the GemFire client to read the data from those regions and show them on the dashboard. It's a Java FX project. It's right here. My laptop's a little bit slow. It should be loading pretty soon. And while this happened, I'm going to show you our last step, that it's basically the simulator that is going to replay all the data. So as we open this dashboard, you guys are going to see initially nothing. Then we're going to open the simulator, let some data flow, and you basically see 3 lines drawn on that chart. First, what's the raw data coming out of it? So coming on the region stocks. that is like the data that is coming live from Yahoo Finance or coming out of the simulator. And next, 2 additional points, lines on that chart. First, what's the real median average? So I want to make very fast transitions and price drops and ups very smooth, so it's easier to predict. So that's the median average. And right after it, what we are predicting as the median average. If you remember well, we're basically inputting the price, the median average, and a simple tech indicator here, relative strength. And I'm basically trying to predict what the next second median average is. So there's going to be a second of latency between the real-time data and what I'm predicting.
The other cool thing about this client also is, since it's using GemFire, it's a GemFire client, we are not actually querying the data from GemFire. We are actually subscribed to a region and saying that whenever we get an update for these particular keys in the region, I want the server to send me a push notification with the update, with the data. So it's actually the server updating the client instead of the client pulling the server all the time. So that's also a nice feature of GemFire.
So if we turn on simulator, and I'm replaying data in random, so you're going to see actually some sharp changes here. I'm starting to pull the data, that's the red one, that's the price. Again, it's like random. It's randomly replayed from like a week of history, so it's going to see it actually changing quick, and it's actually good, so we can check how our algorithm is adapting on the fly. The yellow tag here, or the orange, it's probably looking orange, it's basically what the median average is. You can see it comes up and down, less crazy than the price itself, because it's basically a median average, of course. And then on the green, it's all we're predicting. You see, we're not perfect, because we could be rich if we were perfect, but we are close. And maybe it's not enough for you to make money with that, but it's good to see what you can do. We are predicting, we are really close. When it goes up, we go up. We maybe might missing it for, most of the times, you're between 1.3 and 1.8% of error here, which is a lot if you're trying to trade. But this is a 20 lines of code example. So I'm sure you can pretty much adjust it and use it for a case and actually understand how a machine learning system works in practice. And if you're really curious, and we can restart this, I should be cleaning up this so it makes it easy for you guys to see, but we can restart always the UI, of course. But if you're interested in knowing what the source code for the prediction part of it is, this is basically the project. And by the way, we're going to show it's all on GitHub, so you guys can use it yourself. But the Scala source code that actually does the prediction is ridiculously simple. I basically configure it to read the data from the right GemFire server. I create a new instance of the algorithm. This is the library. I haven't created anything. It's all imported from the raw mlib and Spark. Then you can say, you know what? Read all this data from GemFire here. Apply some filtering. Basically, I'm like, not like NAN, and this is not there, etc. So very simple SQLs. Then, boom, what Markito said. I create an RDD out of it. That means I take that data and I distribute to all my Spark nodes and say, this is now distributed, calculate distributedly. Then I say, these are my tech indicators, they're coming. These are my features, what I'm putting. In this, basically, future median average, exponential median average, EMA, it's basically what I'm looking to get. It's like label. Remember, features, label. Features input, label output. Then I basically scale the data, and I train my algorithm. Save that on a file. And next, if you're trying to evaluate, I basically read from what was saved, takes the inputs, and basically do, hey, predict that for me. The prediction I basically send out to SpringXD again. and it's basically a JSON output. That's it. It's really simple. Maybe 20, 30 lines of code for training, or the 20, 30 lines of code for evaluation. There's no source code for SpringXD, so if you guys remember, the only thing we had was a simple Groovy script, and in the Groovy script are those 5 lines, maybe. I'm basically doing a time format. That's it. That's what the Groovy script does. There's no source code for anything else in SpringXD. Then we have a simulator running Spring Boot. That is, again, this, maybe other 20 lines of code, connects to GemFire, makes a RESTful call to GemFire and replay that data. And then we have the UI. That is JavaFX, so there's a lot of code, but
For the UI.
that's part of Markito's work. We have about 15 minutes for questions, concerns, and by the way,
Can you show the script to submit the Spark job as well?
oh yeah, of course. I haven't shown the script to submit the Spark job. Should be evaluate. So let me make this a little bit bigger. So use a script called Spark Submit. That's what SpringXD is calling. Spark Submit, call this class here. There's my compiled Scala class. Stock inference demo. It's the same one that you were seeing here. Use 1 GB of memory as a driver memory. Also 1 GB for executors. Use those jars as part of the library. Run in all processors in the local machine, so you can actually distribute that for the process. If I had a huge cluster, I could say, of course, the IPs of the entire cluster, so to distribute that. We're not running on my own laptop. And then I'm basically running evaluate to evaluate. And when I'm training, I'm running train. That's it. For source code, how to replicate this, how to build your own stuff, or if you want to change, to send a pull request to us, wherever, it's all on this pivotal open source hub.github.io.
Can you click on the link?
Yep. And
There's actually so all these steps to recreate, because actually what we have here is a Vagrant box as well. So you can run and install everything in your box, but if you don't want to do that, there's a Vagrant box that you can download and just do a Vagrant up. So you have like inside the Vagrant, a VM with everything installed, so you can run everything we did here inside that VM. All these steps to recreate that, including the steps to install the VM, that's actually what you can do if you want to install in your own box, are documented here on this website as well. All the source code, of course, we used, all the streaming, the streams for SpringXD and everything.
And if you have additional questions, I would ask you guys to reach out to us. Sorry. I'll ask you guys to reach out to us on Twitter, and we'll be more than happy to help.
Yeah, and then there's another session that we also talk about Geode from a co-worker or ex-co-worker, John Bloom and Luke Shannon, right? It's actually on the Salon M, so it's close by. It's right after this session, so they're going to talk more about Geode and how to leverage Geode to build like web applications and explore more about Spring Data GemFire. If you're interested in that, I'd like to invite you guys to join that as well. And I'd say now let's open for questions.
Open for questions. I already have one here as well. Oh, that's good. Yeah, sit here.
You mentioned something about R? Could you just give
Yeah.
a little more explanation about R?
Of course. So R, it's basically being used to calculate the technical indicators. It's basically few libraries of math functions. And the reason I'm using that is because when I'm calculating all those tech indicators, and we have a much more complex example that he puts like 8 or 9 of those, I don't want basically to make all those out, to build all those algorithms in either Java or Scala. They already built. But let me open the R applications to understand it's not something really complex. It's what we're calling. So as anything in SpringXD that I'm calling SpringXD, I'm reading from the input, I'm outputting to the output, basically. Standard in, standard out. So if standard in, I read what's coming from the SpringXD streaming, and when I'm outputting back to SpringXD, right? So I start by just reading the standard in, so reading what's coming. I read the lines, and basically I convert it from a JSON to our objects, and then I go to my GemFire or Geode server, as you see, and I basically make a RESTful request. That is a query to read the historical data, because I'm basically calculating indicators based on what's sitting there, right? Then I convert that from JSON again, I reverse the order, and basically I start to apply ready functions in R, like exponential median average. I convert to numeric, I get the exponential median average of the closing price. I could calculate the relative strength, that's the other thing we're putting, based also on a numeric of the close. And I also calculate the difference between the median average and the previous median average, but we're not using this here. I also have the other indicators here ready. They're commented because I'm not using this example, but you could modify and do it yourself. I calculate the inputs, then I have a couple of comments here. So I do some data calculation, and at the end, I output that to my standard out, so it goes back to SpringXD. That's it. And it's like, again, it's probably like 40 lines of code or something in R. You can do that in Java, you can do that in Groove, you can do whatever you want, but you need to build all the algorithms.
The libraries are already built in R. And here, actually, there's a bunch of code that is just actually data transformation. The actual work are actually done by the library itself, right? There's a call to a REST web service.
Other questions? I saw a lot of hands. Yeah?
You're using XD for integration between all these systems. Does Spark have any capability that overlaps? Like, could you just ingest it in Spark?
Yeah. So Spark has something called, so the question is, we're basically using SpringXD to create all the streams and ingest treat data, transform data, and output to what we want to do. So it basically becomes a data integration, a layer there for this example, right? Said, can you just use the Spark for that? You could. So there's something called Spark streaming that actually can read data, convert directly to RDD, and process that data. The problem with that is Spark is a library. It's not a product, right? So you see here we're using mlib for doing our basically machine learning, but we're programming that in Scala. Although that seems simple, that's a very simple example. If I wanted to build all that, use Spark streaming, for example, I'll need to create the source code from ingesting our simulator, for going to Yahoo and querying that, parsing all that data, basically outputting that data to GemFire, then creating a tap to send that data to R, and then it would be a nightmare. I'll be probably showing you 1,000 lines of code instead of showing you 3 DSLs on how to create streams.
We are leveraging all the connector from SpringXD and the nice like DSL to build all the integration. So you could do that in Spark, kind of in the same way you could do that using like plain Java in a way. But the nice, of course, thing about SpringXD that you can just like leverage all the pipeline, and then you have like all the feature of SpringXD itself to scale that streaming between like multiple nodes, monitoring of those streams, like the web, the admin interface, those kind of things.
So
good question.
In my point of view, the perfect world is use the SpringXD to do all that wiring that it could be totally automated, that you want to be scalable, resilient, and automated. If you need, for example, to do some very fancy distributed processing that you need to build source code anyway, you can actually make SpringXD, call Spark Streaming, read the data from Spark Streaming, convert to RDBs, that would probably be 3 lines of code Spark, and then build all your complex algorithms Spark, output that back to SpringXD, and leverage SpringXD automation. That's what I usually do. Other questions?
I see similarities between the GemFire and the architecture of the edge base. Is it the edge base versus GemFire? I see that you have a
Can you
Yeah,
repeat
sure.
the question, please?
So the question was, I see similarities between GemFire and HBase, right? Can we talk about the difference or something like that? Is that?
Was it originally developed from the edge base architecture?
Okay. So the question was if the GemFire architecture was originally based on HBase, right? And the answer is actually no. Actually, the GemFire project has more than 10 years, so it's actually
In
old.
production.
Yeah, in production. So it's incubating under Apache. It's actually funny if you think about it, right? We are incubating under Apache, but we are actually 10 years old, right? But, well, that's the process, right? We have to go through it. But the history, or talking very briefly about the history of GemFire, right? So it started like around 2002, 2004, as like from another company called Gemstone. They were very very eager and very one of the like pioneers with distributed systems like application servers and stuff like that. And they needed like a solution, a better solution for financial markets, right? So then they start building like the core pieces of GemFire. So they want something that could scale. They want something that is very consistent, using in memory, because of course financial systems they require low latency, high throughput, and all that. But of course they're dealing with money, so you don't really want to be like not non-consistent or eventually consistent as like other technologies out there. So like long answer for a short question, no, it's actually
I would probably argue that HBase might have used our architecture.
I don't know.
So it's yeah, go ahead.
I see the Dockers in your GemFire. Have you used Dockers?
So there is another version of this talk or for this content that we also use Docker for the GemFire servers. So all the instructions are on GitHub, and XD as well, yeah, that's right. But just to simplify here and to run on our laptop right now, we're not running that because, for example, actually when we start doing this, we were explaining what is Docker and what Docker does, what's the benefits of Docker, and I think nowadays people already get it. So we are more now actually thinking about running this on PCF, since now we have GemFire service available on Pivotal Cloud Foundry. We have, of course, SpringXD as well. So we may actually change the demo to run there.
Yeah, and the only reason we're not using a web interface, we're using this rich UI dashboard, as William mentioned, is because we want to run the native GemFire library so we can actually get the updates instead of querying it, right? HTTP will not allow you to do that, but if you run this on a cloud platform like on Foundry, you can actually scale your app as instances quickly in containers. You also have XD running containers. You can have GemFire Geode running containers, so you can scale all the pieces of the system in parallel, right? And you can have Spark collocated with SpringXD doing the same. So,
Yeah.
So what's the difference between GemFire and Redis, and when to use GemFire, like if you're in a situation, which one should I choose?
you want to go for it?
Sure. So what's the difference between GemFire and Redis, and where I should use one versus the other? That's a very common question, I would say. I mean, that's a good question, a very common question. A lot of people ask that. So differences, right? When you're talking about GemFire, for example, we offer many other, how can I say that? Many other features or functionalities around the data stored. We are much more focused on the, for example, when you're talking about like when replication, when we are talking about CQ, so continuous queries running against, so the server can push data to a different client. We offer client in the same, like in a bunch of different languages, the same way as Redis does too. Redis as I see, it's very popular, and of course, I think it's like the biggest use case for session replication, which is also something that a lot of our customers and users do using GemFire, but there are some limitations around when and persistence and how we distribute data. So there are some technical or implementation details that are different there. I would say that if you have a need for really only caching data, or if you want to do like counting, you want to do like CRDTs, like distributed counting and stuff like that, Redis may be like the best fit, the best tool for the job. I'm like choose the best tool for the job you have. But if you want like a more, I would say, platform like more complete solution, so you're actually thinking about having distributed processing as well. You want to leverage like OQL. You have like GFish. You have the clustering mechanism as well. So as I was saying before, GemFire is like 10 years old and was always clustered or was always distributed and always with focus on like spanning multiple servers and different use cases as well. But Redis, I think, had cluster and started having cluster like 2 years ago, 1 year ago, or something like that. So stuff like that.
Yeah. So just make that really short as well. I would use Redis whenever you have a very simple caching solution. Most of the data you want to replicate it between all the nodes because you want the clusters, the clients to be partition aware, know where your data is. If you want really high throughput, consistent data model, leverage consistency, have resiliency on a way to identify network splits, be able to replicate different clusters of data. So I might have a geographical distribution of data, like our customers. Like we have actually a financial institution, one of the biggest banks in the world. It's been using geo data locality between New York, Tokyo, and London for over 10 years in GemFire. If you want to have really transactions, AC transactions, low latency, high throughput, data distribution, and processing, I would go for Gem. If you have a very simple web session caching scenario or a very simple data replication solution that want to sit in memory, I would say Redis is perfect. If you want to go beyond that level, like GemFire distributes data in a very transparent way for the clients. The clients doesn't have a clue. Although in the same place, it will minimize the number of hops on the network, build all that resiliency. So it's a more enterprise class solution. Plus, it's born in Wall Street, and it has, I'm only mean Wall Street because of the high demanding requirements. And it's been in production for over 10 years within those requirements. So I would say it's more ready for the enterprise class.
Another
I
question.
might have a last question.
Two more, maybe, yeah.
Yeah.
So my question is more from troubleshooting point of view.
Okay.
Let's assume like there are like 5 filters and 5 transformers and so on and so on. So I don't know if this is the right session for the question, but we saw it, there are tools that do a static representation of the orchestration, like how it moves from one piece to the other. Is there something that at runtime we can discover that same through orchestration? Like derive that data from the logs and then find out the
Can you repeat the question just a little bit?
I'm not sure what the question is.
Yeah.
It's more like, what are your ideas on troubleshooting? Let's assume runtime there is the production related.
Oh,
In XD, in GemFire, in everything?
or in the whole architecture?
Or in machine learning?
The whole orchestration.
I would say that SpringXD is perfect tool for troubleshooting those things. Because at any time, for example, when you're building this, a lot of times you had an issue or an error inside the R script, and all you get is a shell error or something like aborting the system. And I think SpringXD gives you a lot of flexibility for modifying those streams in real time. So for example, instead of sending data to R, I immediately change it to, for example, log. So I'm logging what's input in and what's outputting at. GemFire, in the same way as I'm storing data, I can actually go to JFish and be querying the data to see what's happening over there. Is data coming? It's not coming. Is it stored? What's the format it's stored? I think the automation pieces, both SpringXD and the GemFire ability to have a shell they can query, monitor, and manage that data, makes it very easy to troubleshoot. Spark is a little bit more challenging, but I'm not sure if that answers the question. Like tips and tricks for troubleshooting, I usually use either the SpringXD shell or the JFish or the GemFire shell to do it.
Any more questions? I guess we have
think
time
we
for more
ran
one
out
if
of
you
time.
guys want.
If we have 30 seconds on the last question, will be okay. Otherwise,
Yeah.
we will right on time. Okay, guys, thank you
Okay.
so much.
Thank you.
Have a great day. Appreciate it.